In today's lesson, we're going to practice angle of elevation and depression, and I'm going to go ahead and also upload this full worksheet. We're going to work through the first 3 problems, but the answer key online will have the answer to all of them. So this is a practice that's in your study guide for this chapter. So what I'm going to do is I'm just going to do the first 3. The answers will be online with your study guide. So let's go ahead and get started. It says a guy wire is attached to the top of a 75-foot tower and meets the ground at an angle of 65 degrees. How long is the wire? This is a real-world trig problem, so that means we're always going to be using a right triangle. It's always going to be turned the same direction, and we're never going to use this angle in the corner. That's just kind of habit. We're never going to use it up there. That angle has no relevance. So let's kind of read through the question. A guy wire is attached to the top of a 75-foot tower. Now, a guy wire, that's just a type of wire. We're going to have this random tower. Okay, oh, here's the tower with some doors. Okay, the tower is 75 feet tall. So my 75 goes here. The wire is this. The wire is attached to the top of the tower. It makes an angle of 65 degrees with the ground. The ground is the bottom. So I'm going to put 65 here. How long is the wire? Now the wire is attached to the top of the building. So my wire has to go here. So my X value is here. Angle of elevation and angle of depression problems are common sense. And I know that that sounds like kind of mean to say, but it's a common sense problem. You just have to stop and think about the question and what the question's asking you, and asking you, like how this relates in the real world. So obviously the ground is on the bottom. If I'm talking about distance from the ground, that's the base. Then I have to talk about my height. Height is how tall something is, or altitude. That's always going to be the vertical. And then a ladder, a wire, kite string, that's always going to be diagonal. So that's kind of our little intro. We kind of just need to think about the question. It's common sense, and I can't teach you common sense, as mean as that sounds. You just kind of have to think about it. Once I've drawn my picture, I'm going to go ahead and list my trig functions. So, ka, toa. Okay, SOHCAHTOA. Sorry, there's like something on my paper. All right, SOHCAHTOA. So then I'm going to label across the 90 is H, across theta is O, and this means this side is A. Using the rules of doubles, I'm looking for things with 2 values at the side. So my odd one out is adjacent. So that means I cannot use cosine or tangent. So sine is my trig function of choice. Sine of theta equals O over H. So then I'm just going to go ahead and set it up and solve. Sine of 65 equals opposite 75 over hypotenuse X. To clear this fraction, I always have to multiply by the denominator. So I'm going to multiply both sides by X. And I get X times sine of 65 equals 75. Now I'm not going to pick my calculator up just yet because my variable that I'm trying to solve for is X, and it's isolated. So what I'm going to go ahead and do now is divide both sides by sine of 65. Sine of 65 is just a number, so I can add, subtract, multiply, divide it. Those cancel, and I'm left with X equals 75 sine over sine of 65. Since I'm doing trig, I'm going to go ahead and make sure my calculator is in the right mode. By pressing the mode button, I can see that degree is highlighted, so that lets me know I'm good to go. Pressing clear will get you out of that, and then I'm going to type it in how I see it. 75 divided by sine of 65. Close parentheses, and I get 82.3, or excuse me, 82.8. The 5 rounds the 7 up to an 8. So how long is the wire? It is 82.8, and our units of measure is feet. All right, let's try another one. Remember, common sense problems, you just have to stop and think. Second problem, When the sun's angle of elevation is 57 degrees, a building casts a shadow 21 meters long. How high is the building? So again, my triangle never changes. It's always going to look like this. I'm never going to use that angle in the corner. It doesn't change. The earth doesn't randomly tilt a new way and the ground is somehow now vertical. These problems stay the same, so it's habit. The sun has an angle of elevation of 57 degrees. We always use this angle down here, all the time. A building casts a shadow 21 meters long. So I've got my building. Hopefully the building is standing upright. And shadows are always on the ground. So the shadow is 21 meters long. The ground is on the bottom. How high is the building? That's my X value. If I want to know how tall something is, that's always going to be a vertical form of measurement. And if I have a shadow, that's always on the ground. You cannot walk underneath the shadow. So your shadow is never going to be hypotenuse. Shadows are always on the ground. So I'm going to use trig. I'm going to write SOHCAHTOA. And I'm going to go ahead and label. And I'm labeling the same way I've labeled this whole time. Across the 90 is H, across theta is O, leaving you with adjacent. Using my rule of doubles, X has O, 21 has A, and H is single, so I'm getting rid of H. Sine and cosine are out, leaving me with tangent. So that's tangent of theta equals O over A. Take the time to write it down. No harm in writing it down. Now I'm going to substitute. Tangent of 57 equals opposite X over adjacent 21. To simplify, I always clear the fraction, so my denominator in this case is 21, so I'm going to multiply by 21. These 21s cancel, and I'm left with 21 times tangent of 57 equals X. X is my goal, and X is isolated, so now I can pick up my calculator and do 21 tangent 57. This 3 is not high enough to bump this 3, so it's just 32.3. All right, let's try number 3. Again, these triangles don't change. So I'm going to draw that. A kite is flying at an angle of elevation of 40 degrees. So remember, we never use this angle up here. So my 40 degrees goes down on the bottom. 80 meters of string have been let out. Now this is a kite. You have some random person standing on the ground and they're holding this kite string. And as they fly their kite, oh, there's their kite. Look how great. Okay, there's their kite. As they're flying it, they've let out all 80 meters of string. Kites are never on the ground because I don't fly a kite on the ground. That is a really boring kite. Also, when I fly a kite, it doesn't just float above me. That defies the laws of gravity. So when you fly a kite, the kite kind of leans a little bit. So kite strings are always on the hypotenuse. Ignoring the sag of the string, that just means that the gravity is not holding the string down. It's completely straight, and that lets you know you can use a triangle. And then it says, find the height of the kite. Well, how high above the ground is the kite? Height is always a vertical form of measure. Okay, we've drawn our picture. However poorly it looks, it's still a picture. So I'm going to write SOHCAHTOA. And then we're going to label. Across the 90 is H. Across the angle is theta, or is O. And that leaves you with A. Using our rules of doubles, X has O, H has 80, A has nothing. So A is out, so sine is my function. So I'm going to write that out. Sine of theta equals O over H. Substituting in, I have sine of 40 equals opposite X over hypotenuse 80. I always want to clear my fraction, and I'm going to clear my fraction by multiplying both sides by the denominator. So now I have 80 times sine of 40 equals X. X is now isolated, so that means I can pick up my calculator. 80 times sine of 40, close parentheses. Rounding to the nearest tenth, the 2 is not high enough to bump 4 to 5, so it's going to stay 51.4. So your kite is 51.4 meters above the ground. Remember, these angle of elevation questions, they are common sense. So it helps to sketch what's happening. And some of you might find it easier to draw your picture in a different order. Some of you like to put the angle first, find out where your variable goes, and then find out where the number goes. You don't have to draw your picture in the same order. Just do what works best for you. But remember, the laws of physics apply. These are real world application problems. So I can't just make up some randomness and, say, oh, the ground is vertical. No, it's a real world problem. So you just have to draw a little picture. Obviously, I'm not the best artist in the world, but drawing a picture will help you kind of just visualize it. Or just think about yourself doing this. Think about yourself flying a kite. Think about where shadows are located. You just have to kind of think. And that's why these can be a little tricky, is because you have to actually think about the question and think about how they're being solved.